Hi everyone. It's a great pleasure to actually introduce what we do at Odyssey. But I would like to actually focus on the incubating ecosystem and building on top of what the previous speaker said, focusing on mass adoption. How can you use that into your mass adoption? So look around. You are surrounded by complex problems. Clicker? Yes, thank you. You're part of an interconnected society of complex problems. These problems are not owned by anyone, but everyone gets influenced by them. They don't belong to one nation, but go across borders and include a multitude of complex factors. These complex problems cannot be solved by just one entity. We need to decentralize it to enable everyone to contribute in an unimaginable way, but buildable for the future. That's why we need a public digital infrastructure where everyone can contribute, everyone can build on top of each other, which is completely open source and decentralized. And this public digital infrastructure, it actually thrives on collaborative ecosystems. These ecosystems are interconnected, community-driven. That's what we do at Odyssey. We try to provide an interconnected infrastructure for ecosystems to thrive. And we build the momentum towards it through our hackathon. So to give you an idea about it, this year we actually had 1,500 people brain power solving 20 challenges by building 100 prototypes. But don't take my word for granted. Check it out how our ecosystem rocked this year.
Welcome at Odyssey 2019.
1,500 people working really together and collaborating, that's for sure a start of a transformation.
We are not optimizing the status quo, but really finding new ways to organize our society in a much better way.
The idea is that this rover is able to collect data about the forest. So for example, soil conditions, biodiversity, to give the forest some type of self-awareness.
We're building a disaster recovery system, which essentially is a backup form of internet that activates when all of their systems go down.
So we're trying to modernize fundamentally how we do government. It's a really big challenge.
And people learn from us how we look at those business propositions, and we learn from them. Well, we bring all the information back to the organization, and then we hope we can better supervise. So it's also for better quality supervision.
The energy, the number of people, the amount of help we get from the Jedis and from the organization and everything, it's something else.
The scale is just nuts. How many teams? This variety is just incredible.
And people are thinking up every year again at this hackathon brilliantly new things, and I think we're getting closer and closer to having the technology at a level that this is really scalable.
So we have to outcompete the destructive systems in developing sustainable systems that are more profitable and are better for nature and people.
This event is for the fast one, yeah. Is where you directly show to the clients the product, and they immediately see, like, can they identify themselves with that product, and can they actually help shaping it.
There are so many things that you didn't know and now you found out. You realize how ignorant you are, and then how many more perspectives that can be out there and ways to collaborate to make things happen.
This is an incubator for ecosystems that solve complex problems through mass collaboration.
I think there's a cultural shift with blockchain I've never seen with any other industry or tech. You may be in the same quote-unquote competitive industry, but actually you should collaborate and work together still. The walls are breaking down, and many good things are happening from that.
Well, the hackathon does not operate in a vacuum. We actually have a full open innovation program around it, where we start actually first with articulating very concrete challenges in the context of broader problems, taking multi-stakeholder approach. Afterwards, we create a support system where people can learn and co-create through our deep dives and the hackathon. After the hackathon, our job is not done yet. We actually start incubating the ecosystems that must adopt the solutions after the hackathon. That's why this year we have 20 solutions that are going through our incubator that actually are looking for brilliant minds like you to join their journey into adoption and discovery and growth. That's why you can always go to the solutions.odyssey.org and actually check it out, which one appeals to you most. The next two speakers, two teams, they are two winning teams from our this year hackathon, which happened in April. So you can at least get a taste of what kind of solutions get out of it. But if you're interested in building the next public digital infrastructure, let's connect. Or just join maybe our next year hackathon in April. So save the date, 2 to 6 of April. Thank you.
So hi everyone, my name is Haischel Dabian. I'm the co-founder of Crya, and we're going to be talking about what we managed to accomplish in those 48 intense hours. But before we do that, I'd like to introduce ourselves. So we are a blockchain application startup based in Amsterdam, and our mission is to help organizations adopt blockchain technology. And we do this by providing the full service. So we do capability building, identifying opportunities, validating experiments, doing research and feasibility studies, and doing rapid development. And we do this in a platform-agnostic way, so we don't commit to any platforms. We try to pick the right one for the given use case. So we're kind of sitting as a middleman, ironically, in the space, translating the tech to organizations, giving the tech feedback, and making sure that the implementation is done right for these organizations. So we're here because we participated at the Odyssey Hackathon, and we participated in the Nature 2.0 track. The Nature 2.0 track is all about envisioning the world of tomorrow. So what will this future world look like, and what can we start building today? So building the unimaginable. So what we built this year is actually an iteration upon last year's concept. And last year we focused on swarm robotics, decentralizing swarm robotics operation. The problem that we saw in swarm robotics today is that although it's inspired by nature, many are not mimicking nature. For example, the agents in a network now are communicating directly with other agents in a network by sending messages to one another. But when we look at nature, an ant does not talk to another ant. An ant interacts or coordinates indirectly with other ants through a mechanism called stigmergy. So instead of communicating directly, talking directly to other agents, you interact with a common but dynamic environment. And what we built last year was a simulation for a search and rescue mission. And we had different kinds of machines that would have to collaborate in order to execute the mission successfully. So we had scouting drones that basically roam around, try to find people in distress. We had payload-carrying drones that are able to carry large payloads and multiple other charging stations and repair stations. And how it works was you have a scouting drone that's looking for people in distress, and once he finds someone, instead of sending a message to another machine, he just puts a message in this common and dynamic environment, basically transmitting a transaction to the blockchain network saying, I've found a person in distress here. And that message would be then picked up by other agents who are nearby and who are capable of continuing with mission execution. So that was last year. This year, we were looking at how do we make sure that these machines continuously optimize and adapt to their ever-changing environment. And we looked at the software side, which is decentralizing swarm intelligence, meaning that whenever a machine learns something new or makes a mistake, this learning is immediately broadcasted to the network, ensuring that other machines don't make the same mistake. Now, this can be accomplished through federated learning, which is a technique that Google is using. So instead of collecting data in a central database or central servers, you send the models to the devices, do the computation on the device itself, and then just broadcast the output back to Google. But now, instead of Google, we have a distributed network. I specifically put the asterisk there because, to be fair, we didn't finish the implementation in those 48 hours, but we were close. And the other part is the hardware component. So how do we make sure these machines adapt on the hardware layer? And here we looked at Darwinism, basically. And just like Bitcoin has a heartbeat, with every 10 minutes a block is produced, in our solution we also have a heartbeat, but it doesn't create a block, it triggers an event, an evolutionary event. And this means that the machines in the network will then evaluate their own performance, and this is based off of the inputs and outputs when executing their task. So if one machine can extract water out of soil for 100 kilowatt hours and another can do it for 50, you get an order list of the best performing ones to the least performing ones. And the least performing ones will then be dismantled, and we would then reuse the same components to create children of the best performing machines, creating an ancestry tree on the blockchain. So for example, what you can see here is the machines that have a fitness score of 0 don't get to reproduce, but the ones that have a higher fitness score get to reproduce. So my colleague Dan will be talking about the underlying infrastructure, which may be fundamental in our space.
Cool. Thank you, Haischel. So that's the main idea how we came up to building this. But in order to build it, it's really nice to have a concept laid down, but you want to make sure that your tech is right and you know how to build it really well. So you can actually see that's only a 2-layer genetic tree. Because that's how much we managed to do in the front-end department. Because actually, we make sure that everything is there since block 0. So it actually spawns for millions of applications. And I'm not kidding. It's actually not fake. We do have 1 million applications that we built during the hackathon. So the concept of running off-chain compute in blockchain is not that new. It's just called an oracle because you know that running a computation on a blockchain is very expensive. And you are quite limited by the function set that you get from that specific programming language, such as, for example, in Ethereum, you have Solidity. And next to that, we said that, OK, what if we enable anybody to run what kind of compute they want privately, but trusted, and then only push the outputs to whatever means you want? So for example, you can put the outputs as an oracle. So we use Kubernetes here. And for that specific reason, we actually enable everybody to run a Kubernetes-compliant specifications of an Oracle. And there's this organization called the Ethereum Enterprise Alliance, and they try to standardize some elements of Ethereum. And they have one for this trusted compute, and it's more or less in line with what we have right now. And this is how it looks. At the hackathon, we decided that it makes more sense to build a live system. So every single machine that Haischel was talking about is actually a pod. And that pod is not one unit that has no knowledge of the outside world. Actually, when it gets created, it gets a random UUID, because we need to make sure that they are distinct. But then, that's the trick. So it goes to Ethereum, it generates a wallet, and then we use its address in order to call it. So in this case, we have a blockchain-aware cluster, which hasn't been done before. And this is the reason why we chose to do it. Because now, everybody is aware of how much money every single pod has and how much resources they need in order to continue operating. So this is the coolest part. Now, when you have a blockchain-aware cluster, you can make it live as long as there are needs for the specific technology or specific function that you have. So it's basically like a decentralized function as a service. And yeah, it's all relying on open code. There is no proprietary technology built in because we're just extending Ethereum with Kubernetes. And sorry, that's as much of a demo I have here to show, because if I would actually demo it, it takes me about 10 minutes. And feel free to approach us so that I can actually show you. But that's it. So once you have a Kubernetes cluster, no matter on what provider it is, you just install this new package called Horizon. And what happens in this case is that your cluster is blockchain aware. And now you can actually receive specifications from whoever pays you enough money in order to run their application. So instead of relying on AWS, Google, or Azure, Microsoft Azure, you can have a fully decentralized world where everybody can offer their resources to compute for your oracles. And if you find this as like cool technology and you'd like to know more, you want to work with us, and like maybe you're going to want to figure out what's the better way of doing it, please tell us. We're really curious to hear. And yeah, that's it. Thanks. Take this.
Hi, my name is Jagrut, and my colleague Daisy. Thank you, Odyssey, for organizing such a really good hackathon that I've ever been to. So before the hackathon, we were sitting in the lab trying to decide what's the exact problem that we want to target in this hackathon. And then one of my colleagues, he just started talking about the cool electric vehicle that he just bought and the features that it has. And I was quite impressed by all those things. But then he mentioned a very challenge that he faced in his house. So he lives here in Berlin, in a building which has 20 occupants, has one supercharger, and there are 3 people who owns the electric vehicles. So you guys see where I'm going with this, right? Like, he actually had to wake up in the night to go and charge his car. He talked to a lot of people, to his landlord, to the grid operator, to install another supercharger near his house, but apparently it's very expensive. And that's the exact problem that we targeted in the hackathon. Before that, before we went to the hackathon, when we talk about the climate change or how we want to rethink mobility when it comes to the electric vehicles, we need to address the infrastructure which is going to support this kind of electric vehicle adoption. And right now, there is a bottleneck there that needs to be addressed. And for that, we built a concept. The concept is very simple in its own sense, but it can be scaled to a lot of different complexities. So what was the concept that we built? The concept was that we treat this building that I talked about as a local community. That local community has a parallel split of this one supercharger into 20 different plugs. So when now a user goes to his home or his or her home, he simply plugs the car in the plug. But that does not necessarily mean that the car will be charging at the same point. The car will be charged when the machine learning model that we build is triggering the actual transaction on the blockchain, which then triggers the actual charging on a physical level. And that was what our concept was. And to extend this concept into the future, we also wanted to not only support the vehicle to grid, we also want to support vehicle to vehicle and vehicle to home. And by doing that, we'll be treating this cars, which has huge batteries, not as an consumer of the electricity, but as an asset to the entire community. And by doing that, we can say that it's like a virtual power plant, which you can use when there is a frequency fluctuation or there is a blackout to use as a backup power to charge your home or the entire building. And for exactly like how did we build on the technical details, my colleague here, Desi, will explain.
Yes, so how is this all done? The concept we had includes several components, the first of which is a community management web app. It allows for the users to input their own personal preferences in the app. This can be things like work schedule. For example, every weekday you work from 9 to 5, so you want your car to be charged at exactly 8:30. But this can also be things like overriding that. If, say, at Friday evening you want to go on a vacation, for example, you can just say that, and that would make it happen. Yes, sorry. The next thing we have is the forecasting model. It uses historical demand data, recent supply data, and the personal preferences to calculate when is the best time for the cars to charge. And the historical data is necessary for figuring out the patterns in the energy consumption and production. But this is sometimes not enough, because there may be an unexpected heavy wind somewhere, which might result in a surplus of energy. So this energy needs to be redistributed, and that's what the forecasting model is about. Next, like the scalability of our infrastructure is ensured by using AWS Lambda and Elastic Beanstalk. For the metadata services, we're using Lambda functions, and the metadata services themselves store car and community-related information. For example, the available power capacity in the community or the individual battery capacities in the car. Next, we have the forecasting service, which hosts the forecasting model that I previously talked about. The next one is the virtual power plant, which allows for the community to be seen as an actual power plant. It is an abstraction over the car batteries. And this, in turn, triggers the charging service when it's time for the cars to charge based on the forecasting. The charging service triggers the actual charging stations physically located inside of the community based on the forecasting model. So next, we have the energy consumption itself is tracked by having a smart contract deployed on a sidechain pegged on the Ethereum mainnet. It uses the VATT token to track energy consumption, which means that this token is actually a dead token. Cars acquire tokens by using energy. They can in turn sell that energy back to the grid in times when that is really necessary, or when vehicle-to-vehicle energy transfer is possible. They can also just transfer some energy to their neighbor. We would put the wallet inside of the car, which would make it extremely easy, because the user would just have a charged car at the time when it's really necessary for them, without having to worry about manually doing the transactions. So it is time to change. And the day after the hackathon, we had an incubation session together with automobile OEMs and energy distributors, battery companies, and this is our collective mission. We agreed that we want to enable more electric vehicles by having better access to the charging infrastructure, supporting the grid and the renewable energy in an affordable, open, and agnostic way. And thank you.
Thank you.